Hello everyone, welcome back to my YouTube channel. My name is Prashant and this is a day 2 of my networking series from zero to hero, and in this series we are learning networking from scratch to advanced. This is the day 2 video of my networking series. So let's start with the video, and in this video we'll be discussing multiple things like some basic stuff related to types of network, because whenever you are going to working with networking topics, you will come across multiple types of networks like LAN, local area network, MAN as a metropolitan area network. Sometimes you can also see like PAN is there, personal area network, WAN, that is wide area network. Then after that you will come across some of the topologies, okay, like mesh topology, bus topology. So there are multiple types of topologies in the computer networking that actually represents how your network skeleton is, how your network is going to look, what is the actual layout of your network will be represented by your topology. And once we are having a basic understanding of topology, then we'll discuss the one of the most important parameter in the networking, that is addressing. So coming down to addressing, we are going to discuss two types of addressing. One is MAC addressing. MAC stands for media access control. Actually it's a physical address that is used within a LAN, and another one is logical addressing, in which we are going to discuss about IP addressing. That is one of the most crucial and most important part of this networking series. So that will be in the next video, and we'll discuss about MAC, and we'll discuss how combination of IP address and MAC address is going to work together whenever you want to send a data from source device to destination device. And then we'll discuss about some protocols like ARP protocol, how a broadcasting is done. So this kind of things we are going to discuss in today's video. So let's start the day 2 of this networking 0 to hero series, and this series is totally taken from a scratch to advanced level. So make sure to watch a day one video instead of watching this, because all the videos are interlinked with each other. So if you are not watching day 1, so definitely you will feel certain gaps while understanding the day 2 video. So make sure to watch day 1, and this is the day 2. So let's start. So whenever you are going to work with networking, you are going to come across types of network, or multiple times you must have heard about types of networks like LAN is there, MAN is there, WAN, PAN as a personal area network. So there are multiple types of networks, and based upon the size of network, this classification is done. So overall, from upper view, if you see, there are 3 types of networks. One is LAN, MAN and WAN. LAN stands for local area network, MAN stands for metropolitan area network, and WAN stands for wide area network. So let us understand what is a LAN network. LAN network is nothing but a group of computers and the devices that are connected usually in a same building or within a room. So in the last session, as we already discussed, whenever you are going to discuss about network, so network is nothing but when 2 or more than 2 devices, when 2 or more than 2 devices are interconnected with each other, then we are going to call it as a network. Okay, when 2 or more than 2 devices are interconnected with each other in order to share the data or in order to exchange the resources, then it is called as a network. And there are multiple types of network. And if you see about LAN network, so LAN is also a network in which multiple devices are interconnected with each other. But a network that is usually in a same room or a same building is referred as a LAN network. So if you see the example, your home network. So inside your home, there are multiple devices that are connected with a router, or multiple devices are a part of one network. Like your mobile phone is connected to your router, your laptop, your smart TV is connected to your router. So within your home, within your building, you are connected to a router. Such type of small networks are mostly referred as a LAN networks. Such type of networks are called as LAN networks. Or for example, you must have observed in your childhood days, inside your computer lab there were multiple computers that were interconnected with each other. There were multiple computers that were interconnected with each other. So within a single room or within a floor or on a floor, so when the multiple devices are interconnected with each other, then we are going to call it as a LAN network. Then we are going to call it as a LAN network. One of the best example of LAN network is your home network, where multiple devices inside your home are connected to a router. So that is a kind of network. So you can refer it as a LAN network. Second type of network is nothing but it's a metropolitan area network. If you discuss about metropolitan area network, in metropolitan area network, the devices are interconnected across several buildings in a city. So for example, let us take example of Pune. So in Pune we are having multiple places. We are having Wakad, we are having Baner, we are having Aund. So there are multiple places. So within these multiple places, for example, we are having a HDFC Bank which is located in Aund. So for example, this is a Pune map, okay, and this is some X place, this is some Y place, this is some Z place, and yeah, here we are having one bank, here also we are having one bank, and here also we are having one bank. So multiple places within a city are interconnected with each other. Such type of networks are called as metropolitan area network, a network that are span across several buildings in the same city. Kind of a banking network, a network connecting multiple branches of a banks within a same city is kind of metropolitan area network. So in order to understand the LAN, MAN and WAN, what I can tell you is, based upon the size you can think of it like LANs are the small network. Actually, if you dig down more, this is not the correct way to segregate or to classify the different types of networks, because a LAN can be a network within a city as well. But for your understanding, you can say small networks are basically a LAN networks which are not having internet connectivity in them. MAN are the like networks that are span across multiple buildings in the same city, and WAN is a wide area network. Okay, third one is the WAN. WAN stands for wide area network, a network which doesn't has any geographical restrictions. For example, a network that is span across entire world. One of the best example of WAN is internet or a global banking network. So when you come across the types of networks, always keep in mind there are three types of networks. One is LAN, another one is MAN, and third one is MAN. LAN stands for local area network, a network that is usually span within a room, within a building. Okay, your home LAN, your school LAN, a cyber cafe LAN is always there. Metropolitan area network, MAN networks are networks that are span across entire city, connecting multiple branches within a city. Then we are having WAN, wide area network. Wide area network actually doesn't has any restrictions. Okay, it doesn't has any geographical restrictions. So when multiple countries and nations are interconnected with each other, such type of big networks are called as WAN, wide area network, like internet or any kind of global banking network. Okay, so if you see the example of LAN, so you can see inside your home, a router is connected to multiple devices like laptop, tablet, smartphone. So it's kind of LAN network that is usually within a building or within a single room or within on a particular floor. But when you come across MAN network, in a MAN network you can see multiple government buildings or multiple buildings are connecting with each other within a city. Such type of networks are called as MAN network. And the last one is nothing but WAN, that all of you know it's a wide area network. For example, internet. Internet is nothing but it's a network of networks. So it is span across entire world. Such type of networks are called as WAN, wide area network, or any kind of global banking network that is going to connect multiple banks across different cities, states and countries. Such type of networks are called as, or generally are referred as, WAN, wide area network. Okay, so just keep a basic idea about types of network, because when you're going to work as a cloud engineer or a DevOps engineer, you're not going to configure these kind of networks, because all these kind of networks are being configured on cloud service provider. Okay, so just have a basic idea about LAN, MAN and WAN. Now if you come across next topic, that is network topologies. Okay, so network topologies, whenever you are going to discuss topologies in computer networking, there are two types of topologies. One is physical topology and another one is logical topology. Coming down to physical topology will tell you the actual layout of your network, how your network is going to look like. Okay, how your network is going to look like, a skeleton of your network, or another name for topology is nothing but it's a design. It's a design. So how your network is going to look. Okay, so when you draw a diagram of your network, or what is the actual layout of network, these things are represented by your physical topology, kind of diagram of your network. Another type of topology is logical topology. In logical topology, we are actually going to understand how devices are going to communicate internally, how a data is going to flow in the network. So for example, if you see, I am having one network in which I am having a device which is connected to B, okay, which is connected to B device using switch, and here I am having C device. So in this network you can see you are having a three devices. Okay, device A, device B and device C, and all of them are interconnected with each other using switch. All of them are interconnected using switch. Okay, now if you see about this switch, okay, it is one of the networking device that we are going to discuss in upcoming sessions as well. Okay, so if you see about this networking device that is helping us to connect multiple devices in a network. So if you see a view of your network, this is how it is going to look. So the actual layout of your network or the diagram of your network is represented by a physical topology. But when it comes down to a logical topology will help you to understand how a data is going to flow. So data will come from A and transparently it will be given to B with the help of switch. So how a devices are going to communicate internally is actually represented by a logical topology, and how is the design of your network is actually represented by your physical topology. Now let us understand physical topology, and in upcoming sessions when we'll discuss about addressing, okay, when we'll discuss about addressing whether it's a physical or it's a logical, after that we are going to understand logical topology. Okay, so first of all let us understand what is a physical topology. So as of now you know physical topology is nothing but it's a layout of your network, it's a diagram of your network, it's a skeleton of your network. So one of the topology you will come across is mesh topology, where each node, each host or each device is interconnected with each other, okay, with the help of cable. Now this mesh topology provides very high level of security, because we don't have any centralized machine that is connecting multiple devices, so it provides very high security. But there are some disadvantages about this mesh topology. One of the disadvantages of this mesh topology is scalability. Scalability is nothing but increasing the things, expanding the things. So mesh topology doesn't promote scalability. So for example, if I want to add one extra node inside this network, so for example I want to add one device, okay, so this is my device number 6. Okay, if I want to add this device to this network, I will have to connect, okay, this new device to all the devices within a network. So while expanding this network, there is a lot of overhead I need to do. Okay, so mesh topology doesn't have scalability. Okay, it doesn't provide that much of scalability. And another problem with the mesh topology is it's little bit complex, and it's little bit costlier, because multiple cables we need to use here. So that is why cable cost will significantly increase the cost of entire network. So mesh topology provides high security, but it doesn't promote um, scalability and cost optimization of this network. So this is how a mesh topology is there, where every node, every device or every host is connected, okay, independently with each other. Now second kind of topology is nothing but a bus topology, a kind of bus like structure you can see here, where multiple nodes are interconnected with each other by using a centralized cable called as trunk. So this centralized cable is called as a trunk, and with the help of this trunk multiple devices are interconnected with each other. Multiple devices are interconnected with each other. Okay, so so it was mostly used in the olden days. Okay, and this is called as a trunk. But one of the issue with the this bus topology kind of networks are nothing but these kind of networks are totally dependent on this kind of trunks. So if there is some breakage of this trunk cable, so there will be a disconnectivity between multiple devices in a bus topology. But what are some advantages? It has good network performance and high level of security. Also it is going to reduce down the collision domains and multiple stuff it is going to work with. But this kind of topologies where a bus kind of architecture you can observe are called as bus topologies. Third one is star topology, and it is widely used topology nowadays as well. Okay, so mostly if you see a network, most of the networks are nothing but a star topology, in which a star kind of structure you can observe here, where multiple nodes are interconnected with each other using one networking device, that is switch. Networking device we haven't discussed it. Okay, but in the next session we are definitely going to understand the working of switch, router, hub and rest of the things. But if you see in the star topology, multiple devices and the nodes are interconnected with each other using a networking device, and in this case we are using switch, so it is widely used. Okay, then we are having ring topology. Okay, where every device is connected with every device is okay, adjacently connected with each other using a cable. Okay, so kind of ring structure you can observe here. Okay, and at the last we are having some tree like structure, where if you draw a tree, okay, if you draw a tree, so this is the tree. Okay, I'm drawing it in a different angle, but if you see, okay, so a tree like structure is observed here. So a hierarchical structure of stuff is added here. So we'll having some hierarchy. Under this we're having two devices, above that we're having multiple devices. So this kind of topologies are going to call as a tree topology. And the last one is hybrid topology. Inside hybrid topology, what generally is going to happen is we are going to use multiple different topologies together. For example, I am using, okay, ring topology here. Okay, in this I am going to use here mesh topology, and in this I am going to use star topology. A network in which multiple different topologies are used, such type of networks topologies are called as hybrid topologies. Okay, where the combination of two or more different network topologies are being used. Okay, so you don't need to like provide that much of attention at topologies, because whenever you are going to work with network topologies as a cloud engineer or a DevOps engineer, you won't be able to, or you won't be asked on this kind of topics, but these kind of things will make you a good engineer. Okay, because I have seen multiple students making mistakes while starting their career as a cloud engineer or DevOps engineer, because if you are not having understanding about basics of networking, definitely while learning cloud concepts like VPC, ENIs, EC2, so you won't be able to grasp, or you won't be able to get the connectivity while learning cloud concepts. If you are not having understanding about networking, then you will face the problem while dealing with Kubernetes, because you won't be able to understand node, port, services you won't be able to understand, Docker network, Kubernetes network. So it's very much important to understand networking. But make sure your goal here is not to become a network engineer. Your goal here is to become a cloud engineer or DevOps engineer or any other engineer. In this 0 to Hero series, we are covering entire fundamentals of computer networking from very scratch to advanced level. Okay, so I will focus on the main topics more, because topologies are something that are it's kind of traditional topic. Okay, but having a understanding about topology is also important. Okay, now after that let's start with the actual networking. Now we'll enter the actual networking, that is nothing but addressing. We'll enter the actual networking, that is nothing but addressing. Okay, addressing. Now till now we have discussed how devices are connected with each other. Okay, till now in the last session and few minutes of today's session, we have discussed how devices are connected with each other. As of now I am having an idea that in a network multiple devices are interconnected with each other using a networking device called as switch. Okay, but how a data is going to travel, how one device is going to identify other device. For example, in a room there are 4 to 5 people are sitting. So how one person is going to identify another person? By using their names, by using their Aadhaar card addresses, kind of stuff. Okay, so what I am trying to say here is, when multiple devices within a network are interconnected with each other, then how one device is going to identify another device. Okay, so if I want to send a data from one device to another device, but how do I identify that another device? Okay, for example, I want to go somewhere, but how do I identify where I need to go? So here comes addresses. Here comes addresses. Okay, the basic or the significance of addresses in computer networking is to identify a device. To identify a device, that this is the destination device, and any data that I want to send from source device to the destination device should be sent at a particular address. So having an address understanding is very much important, because in upcoming sessions you are going to learn IP addressing in very depth. So having a good understanding about addressing is very much important. So what I am trying to say, if I am having a network in which multiple devices are interconnected with each other, and if one device wants to send a data to another device, so you should have the understanding about addresses, because without knowing address of destination device you won't be able to send the data. For example, if you want to go somewhere, if you don't know where you need to go, you won't be able to go. Similarly, in a network when multiple devices are interconnected with each other, if you want to send the data to destination device, but you don't know where the destination device is sitting, you don't know the address of that, so you won't be able to send the data. Okay, so in a network, okay, or to identify the devices in a network, we need addresses. We need address of this device. So if I'm having multiple devices in a network, definitely I will need an address to identify that specific device. Okay, to identify that specific device. Okay, now what is that address? Whether it's a area address, pin code, what kind of address they are having. So when it comes down addresses in networking, there are two things you need to keep in mind. One is IP addressing, also called as logical addressing, and another one is MAC addressing. It is called as physical addressing. It is called as physical addressing. So what I am trying to say here is, so when it comes down to addresses in computer networking, there are two types of addresses, IP addresses and MAC addresses. Now in today's session we will understand what is a MAC address and how MAC address is going to help us to send the data from source device to destination device. So MAC stands for Media Access Control. MAC stands for Media Access Control. So to identify any device in a network, okay, to identify any device in a network, I will need a MAC address. Okay, I will need a MAC address. So if you see about this MAC address, so if I am having a network, for example, I am having A device connected to B devices using a switch. Okay, so what I am trying to say here is that there are multiple devices that are connected with each other with the help of networking device called as switch. So if A device wants to send the data to B, so A device should have an idea about B. A device should have an MAC address of B. Without knowing the MAC address of my B device, A device won't be able to send the data. So if one device wants to send the data to another device, so that device should have an understanding about MAC address of that destination device. Now what is that MAC address? So whenever you want to discuss about MAC address, it's a 48-bit number. It's a 48-bit alphanumeric number. Okay, and it is unique in globe. It's globally unique. It means if I am having a MAC address, for example, A12345BC8, so this MAC address will not be assigned to any other device in this world. So no two devices in this world will have a same MAC address, just like your Aadhaar card number. So or just like your social number. For example, you are having a Aadhaar card number. Your Aadhaar card number is globally unique. So no other person in this world will have same Aadhaar card number as your. So it's a globally unique. Similarly, in this world there are billions of devices. Every device in this world is having a unique address. That unique address is called as MAC address. That unique address is called as MAC address. And what is the use case of this MAC address? Whenever I want to send the data from one device to another device, I should know the destination MAC address. Without knowing the destination MAC address, I won't be able to send the data. Now this MAC address is also called as a hardware address. This MAC address is also called as a hardware address. Now why it is called as hardware address is because it's fixed. So if you are having a MAC address to a device, and if you are in Pune, or if you are in Delhi, if you are in USA, if you are in South Africa, your MAC address is not going to change. So it's a permanent address unless and until you change your kind of some physical component or physical hardware component of your device. But MAC addresses are globally unique and it's a hardware address. So where this MAC address is written, now these kind of MAC addresses are written on your NIC card. And in the last session we have already discussed what is NIC card. NIC stands for Network Interface Card. It's a chip inside your machine or a device with which you are able to communicate with another devices, or with which you are able to become a part of any network. So what I am trying to say here is NIC card is nothing but it's a chip, it's a hardware component, it's a heart of your network, and above that on that NIC card you can see on that NIC card you can see your MAC address is written. So if you go on internet, if you try to search NIC MAC address, okay, and if you go to images, so kind of yeah, so in this diagram you can easily see the MAC address is written on your NIC card. That is why most of the time you are going to call it as a hardware address, physical address, MAC address. So there are multiple names, but MAC address is written on your NIC card. Now can I see MAC address of my device? Definitely you can see the MAC address of your device. Open the command prompt inside your Windows machine and search for ipconfig/all. If you search for ipconfig/all, it is going to provide you a bunch of information, and inside this information you can identify MAC addresses. So if you want to see the MAC address of my device, so this is one MAC address, okay. Then we are having another MAC address, okay. This is another MAC address. Then we are having some another MAC address, okay, also called as physical address. So why I am able to see multiple MAC addresses here? So can I say my device is having multiple MAC addresses? So the question here is, do one device have multiple MAC addresses? Yes or no? Do one device has a multiple MAC addresses? Yes or no? So the correct answer is yes. One device can have multiple MAC addresses. Now how one device can have multiple MAC addresses? Because one device is having multiple NIC cards. Because one device is having multiple NIC cards. Now why one device is having multiple NIC cards? The reason it is having multiple NIC card is because one device has multiple modes of communication. Like my device can communicate with another device using Bluetooth. My device can communicate with another device using Wi-Fi. My device can communicate with another device using some kind of physical medium, physical cables, okay, physical medium or physical cables. So what I am trying to say here is that one device is having multiple MAC addresses because one device is having multiple NIC cards, and one device is having multiple NIC cards because one device can communicate in multiple different modes, like Bluetooth communication can happen, like Wi-Fi communication can happen, kind of some physical communication can happen, okay. So that is why when you open your command prompt and when you execute ipconfig/command, here you can see multiple MAC addresses. So if I am communicating with the help of Bluetooth, so this kind of MAC addresses will be used. If I am connecting through wireless LAN adapter, that is Wi-Fi, I will be using this one, okay, C492.024732. If you want to communicate with some physical medium like some kind of Ethernet adapter, okay, then this kind of MAC addresses will be used, okay. So one device is having a multiple MAC addresses, okay. So it's a 48-bit alphanumeric number, and when you discuss about MAC addresses, if you see any kind of example, okay, so this is how you are going to see the MAC addresses. For example, like 4B, 1C, 88, 91, 1A, okay, this kind of alphanumeric address you can see, and hyphen is used in Windows and colon is used in Linux, okay. Now as we have discussed here, in addresses I am having two addresses, MAC address and IP address, and till now I have told you that if I am having two devices, A device and I am having another device, that is B device, okay. So if I want to send the data from A to B, A device should know the MAC address of B, okay. If I am having the understanding about MAC address, then why I need IP address? Why I need two addresses? Why not just by MAC we can communicate with multiple devices, or why not just we are using IP to communicate with all the devices? Why we are having a MAC address, or why we are having IP, or why we are having both the IP addresses? So if I can send the data from one device to another device using MAC, then what is the use case of IP address? And that is what we are going to learn now, okay, that is what we are going to learn now. So when you discuss about MAC address, definitely you are going to discuss about IP address as well. So just by having a MAC address, okay, just by having the MAC address, things will not work. Along with this MAC address, I will also need IP address. By using a combination of MAC address and IP address, I can send the data from one device to B device. If I am having just IP address, things will not work. If I am having just MAC address, things will not work. I need both of them to send the data from source device to destination device. Then what is the purpose of MAC address? What is the purpose of IP address? The purpose of IP address is to locate the device. Where is that device? And the purpose of MAC address is to talk to that device. So with the help of IP, I will identify which is the device, and with the help of the MAC address, I will talk to the device. Okay, I will talk to the device. So let us take one example, and with the help of that example, we will understand how combination of MAC address and IP address is going to work together. So if you see, let us draw one network. Okay, I am having a network. Okay, a device is connected to a switch with a B device, and I am having one more device called as C device. So in front of you there is one network in which you can identify there are 3 nodes, and all the nodes are interconnected with each other with the help of switch. So switch is a networking device that helps us to connect multiple devices or multiple hosts in a network. Okay, in upcoming sessions, maybe in the next session, we will discuss about these things. Okay, but yes, okay, so I am having a network. Inside that I am having 3 devices: A device, B device and C device. Now I am assuming I am having a MAC address. So this is the MAC of A, this is the MAC of B, and this is the MAC of C. So I am having 3 devices that are connected with each other, and every device is having a MAC address. Now who is going to give this MAC address? Okay, who is going to give you this MAC address? Now this MAC address is given by the device manufacturer organization. So the organization that is going to manufacture this device will provide the MAC address. So for example, currently I am using HP laptop. Now the HP organization has given a MAC address to this device. For example, if you are having Dell, okay, some students will have Lenovo. So a company which is manufacturing the device is responsible to provide the MAC address. So when you go to the market to bring a new machine, so that machine is already having a MAC address, and it is never going to change. Even if you restart it multiple times, the MAC address will be like static. It is never going to change, and it's a unique address in the world. Okay, so in a network I am having 3 devices connected with each other, A, B and C. Every device is having a MAC address. Every device is going to have a MAC address. Now if I want to send the data, okay, now if I want to send the data from A to B, okay, I want to send the data from A device to B device. Okay, so how does my A device knows that B is sitting here? Why A doesn't mistakenly send the data to C? Why A is not going to make certain mistakes and send the data to C? So how does my A device know where my device is sitting? MAC address will not help me to identify where the device is sitting. MAC address will help me to send the data to this device, but before sending the data, I need to identify where the device is sitting. This should not happen that at this place a wrong device is sitting and I am sending the data. No. So MAC address is needed to send the data from one device to another device, but where that device is, okay, where that device is located. So in order to locate any kind of device in a network or across a network, we are going to use IP address. We are going to use IP address. Okay, so the main purpose of IP address is to locate the device, that where that device is sitting. And how you are going to know where that device is going to sitting? That is with the help of IP address. Okay, that is with the help of IP address. Now in this network, okay, if you want to send the data from A to B, there is one condition that you need to follow. If you want to send the data from any device to any device, if you want to send the data from A to B, one prerequisite is that you should always know the destination IP address. You should always know the destination IP address. So how my A device will know the destination IP address? As a user, okay, as a user, I am going to provide the IP address to A device. So as a user, I will tell to my A device, okay, this is the destination IP address 192.168.1.2. You need to send the data here. So as a user, I have told to A device that this is the IP address that you need to send the data. Now IP address is not used to send the data, MAC is used. Okay, so basically the combination of IP address and MAC address is going to work together to send the data, but with the help of IP I will identify, okay, here is the device that is sitting and I need to send the data here. Okay, now just by having the IP address, just by having the destination IP address, things are not going to work. Along with the IP address, I will need a MAC address. So does A knows the B's MAC address? No. Does A knows the C MAC address? No. Does A knows the B's IP address? Yes. So my A device already knows the IP address of B. How does A knows the IP address of B? As a user, I have told that hello A device, you need to send the data to this B device, and this is the IP address of B device. So A device has already got the destination IP address. Now one thing that is missing right now is destination MAC address. Now in order to get the destination MAC address, there is one mechanism that is going to perform, that is called as ARP. ARP stands for Address Resolution Protocol. ARP stands for Address Resolution Protocol. So what is this ARP? ARP is nothing but with the help of IP address, I will get the MAC address. Okay, with the help of IP address, I will get the MAC address, and once I am having the MAC address, then I will send the data. So in the ARP, what is going to happen? My device is going to broadcast one message. So my A device is going to broadcast one message to all the devices in a network, to all the devices in a network, and inside that broadcast message, A is going to tell, do you have the MAC address of this device which is having this IP? So for example, the broadcast message has received to C. So C device will open that broadcast message and it will read it. So in that broadcast message, what it is written, do you have a MAC address of 192.168.1.2, and C's IP address is 192.168.1.3. B's IP address is 192.168.1.2 and A's is 1.1. So in this broadcast message, broadcast is nothing but sending one message to all the devices in a network. Okay, so if you see in that broadcast message, it is written, do you have a MAC address of 192.168.1.2? Now C will read that message and C will say, my own IP address is 192.168.1.3. How I can give a MAC address of this IP? No, I am not the right person. So C will reject that message. Now same message is also broadcasted to B device. Now B will read the message, and inside that message it is written, do you have a MAC IP of 192.168.1.2 IP address? So B device will say, oh, like he is asking the MAC address of myself. So in response to that request, B device is going to send the MAC address. So B device is going to send the MAC address. Whose MAC address it is going to send? B device's MAC address it is going to send. Now this device is having two things, destination IP address and destination MAC address. Once my device gets destination IP address and destination MAC address, now I can send the data from one device to another device. Now I can send the data from one device to another device. So what I am trying to say here is, if you want to send the data from one device to another device, just by having the IP address or just by having the MAC address to that device, things will not work. In order to send the data from source to destination, it will use both IP and MAC. IP it will use to identify which is the device, and MAC will be used to send the data to that device. So let us take one more angle, one more shot to understand this ARP stuff. Okay. Yeah. Okay. So to communicate, we need both combination of IP address and MAC address. Okay. So same example, if my host 1 wants to send the data, okay, if my host 1 wants to send some data, okay, so let me take a good color, maybe, okay. So my host 1 wants to send the data to host 4, okay. So if any device wants to send the data to any other device, so destination IP address I should know. So my host 1 should know the IP address of which device? Host 4. So assume host 4 is having 192.168.1.4. So as a user I will tell, hello host 1, send this data to host 4, and this is the IP. Now just by having IP things will not work. Host 1 will need MAC. So how host 1 will take the MAC address? By using ARP protocol, address resolution protocol. The main purpose of this protocol is to resolve the MAC by using IP. So by getting IP, I will find out a MAC. So what I am going to do here is that host 1 will send a broadcast message to all the devices inside that network that do you have a MAC of this device 192.168.1.4. Host 2 will reject that message that I am not the right person to send the MAC because my IP is different. Similarly, host 3 will also reject that message saying that I am not the right device to send you the MAC address. But coming down to host 4 will look into the message and it will read it. Okay, you are looking for the MAC of 192.168.1.4. I am that device. Take the MAC address. In response to that ARP broadcast message that host 4 has received, host 4 will respond with the MAC address and it will give the MAC address to whom? Host 1. Now host 1 has received the MAC address. Host 1 has received the MAC address. Now host 1 is having both IP and MAC. Now host 1 can send the data from source to destination. So what I am trying to say here is, if I want to send the data from any device to any device, this device should know the IP of that device to locate that device where the device is sitting, and this device should know the MAC to send the data. Without having MAC you won't be able to send the data, and without knowing the IP you won't be able to identify the device where that device is sitting in a network. So in order to send the data from one device to another device, it should know both IP address and MAC address. The main purpose of IP address is just to find where the device is, and MAC address will help me to go to that device. Okay, so this is how things are going to work. So let us take one more example of MAC address in layman's term, because when you discuss examples in layman's term, it becomes very easy to understand how things are going to work. Now in order to understand this, let us take it from here only. So think of it like you are here and okay, you are at your home and there is one gift that you need to deliver to your friend, and your friend is located somewhere office. He is sitting in office right now and you want to surprise him or her. Okay, most probably her, because you won't give a gift to a male friends because some different reasons. But let us take example that you are giving some kind of gift to one of your friend, and she is sitting in office, okay, and the address of that office is, for example, West Avenue, office 122, okay, Aund, Pune 411033. So this is the address, this is the office address, okay. Now think of it like you don't know the address. Will you be able to deliver the gift to your friend? No. Without knowing the address, you won't be able to go there only, okay. So having an address is very much important, because you know where I need to go, okay. So this is the address. Now within that address, multiple employees are currently working. So what I am trying to say here is that this is nothing but IP address, that where you are currently right now, and to go to there you will need a MAC address, So this is how things are going to work, combination of IP and MAC, okay. Now in the next session we'll discuss about networking device, okay. In the next session we'll discuss about networking device like switch working, router working, and all these things, and then we'll discuss this example, okay, that across the network how communication is going to happen using ARP. So if you conclude today's video for day 2 of networking 0 to hero, what things you have learned? Okay, initially we started with types of networks, that is LAN, local area network, metropolitan area network, and wide area network. After that we have learned topologies, in which mostly we have learned physical topology. Physical topology will tell you how is the architecture of your network, how your network is going to look like, okay, what is the actual layout of your network. So we have seen multiple types of topologies like mesh, bus, star, ring, hybrid tree, okay, XYZ. After that we came down to addresses, because अगर आपको कहीं से निकलना है और कहीं पे जाना है, सो कहीं पे जाने के लिए वहाँ का आपको एड्रेस पता रहना चाहिए. Similarly in a devices, similarly in a network, multiple devices are there. So if one device wants to send the data to another device, you should know the address of another device where you need to send the data. So address comes with two things, okay. So there are two types of addresses, MAC addresses and IP addresses. Now IP address will help me that device is sitting here. MAC address will help me to go there, okay. So by using the combination of IP address and MAC address, you are going to send the data from source device to destination device, okay. And in the next session we will discuss about networking devices. Along with that we will discuss about this example, router example we will understand, very much important, okay. Then we will deep down in IP addressing. So we are done for today. Thank you guys for watching this video. If you really like the video, okay, like it, subscribe to this channel, and comment down your thoughts, like how you are thinking on this, okay. Comment down how you like, do you like this session or not, and make sure to subscribe this channel Prashant Gaute, because whenever I am going to upload any new series or any new videos, you will get the notification. So thank you guys, thank you all for watching the video. Let us meet in the next video. Have a good day.